This is my showreel for my final year project using machine learning to identify phishing links. There have been projects in the past similar to mine, but none have used the data only given in the URL. For example, a past project used features of the URL combined with information such as what country the website is registered in, its IP, and other information from its whois.com page, while another used Google's search engine algorithm to determine a link's trustworthiness. I chose this project as many people still have trouble identifying phishing URLs from legitimate ones, and one lapse in judgment can cause passwords to be changed or bank account details to be stolen. So for this project I first needed datasets containing phishing links and non-phishing links. To collect phishing links I used fishtank.com. Fishtank is a community-driven website where users can submit suspicious links and others will vote on whether they think they are phishing links or not. Anyone can go on there and download parts of their database in one click. This dataset you see here contains 27,000 links, dating back from 2008 to the beginning of this year. The columns of the spreadsheet show each phishing link's unique identifier, the URL itself, the URL Fishtank has given it, when it was submitted to Fishtank, is it a phishing link, and when it was verified, is the website still online? Yes, all websites in this sheet are currently online, and the target of the scam. You can see Facebook, Microsoft and PayPal in the column on the right, but any company you can think of is on here, such as Amazon or Netflix. In this sheet you can see the safe links that I collected, roughly 12,000 in total. I did this by using Jasmine Directory. Jasmine Directory is a web directory that categorizes websites through filters such as country and what type of business they offer, for example arts and humanities or health and fitness. Unfortunately Jasmine doesn't have a one-click download button for their database like Fishtank did, so I had to go through each web page myself with a URL extractor and copying the results into this spreadsheet. Now that I have my datasets, I reduced the phishing set to the same amount as the safe set and combined them into one single spreadsheet. From here I'd needed to decide what features to add to the data that would help Weka identify the differences between a phishing link and a non-phishing link. I started with lexical features such as how many hyphens, dashes, equals signs, colons and semicolons, @ signs, underscores and full stops there were in each link. I then added numerical features to the dataset, which are highlighted now. These include how many ones, how many twos, all the way up to how many nines, as well as the total amount of numbers in each link. After this, I added keywords to the dataset. I did this by removing all alphanumeric symbols from the dataset and putting it into a word frequency calculator. The results can be seen highlighted, with safe links being on the left and unsafe links being on the right. After analysing the results of the word frequency calculator, I added how often the words login, index, pay, web, mail, free, gov and wiki appear in the hyperlink to the dataset, which can be seen highlighted now. The final features I added to the dataset were how long the hyperlink itself is and how many upper and lowercase letters there are in each link. From here I split the spreadsheet 70-30 into training and testing datasets ready for use in Weka. This is what the training set looks like when it is loaded into Weka. From here I ran various different tests on the dataset to gather information on the accuracy of the classifiers, how often errors occurred, and tweaking the settings of each classifier I ran to see how the results would change. I also removed features that I thought were performing poorly to see if there are any improvements to the results, and I used 10-fold cross-validation for all testing, and the full results can be seen in my report. I also ran 3 different attribute evaluator algorithms on my dataset: correlation, gain ratio and wrapper. These algorithms look at each individual feature and decide how important that feature is to the overall identification of a phishing URL. Highlighted now are the results of the correlation evaluator that shows the amount of slashes and lowercase letters that are in the link, as well as how long the link itself is, are the 3 most important features to phishing link identification. And at the bottom you can see that the amount of times the words wiki, gov and free appear in the link are the least reliable features when it comes to identifying a phishing link. After assessing the results of each attribute evaluator, I narrowed down my dataset to 15 features, half the amount I previously had, and began testing the dataset again using the same parameters as I did before with the full 30 features. The results of this testing showed improvements in accuracy in nearly every classifier I ran, as well as reduced error rates across the board. After further testing, it was clear that random forest was the best classifier in terms of both high accuracy and low error rates, being able to correctly identify if a link was phishing or not 91.269% of the time. The results of this I'm scrolling through now. Similar past projects to mine also had random forest as the best classifier for phishing link identification, and what I have found in my work agrees. So to conclude my work, I have proposed a new purely URL based way of classifying phishing URLs either as safe or unsafe. I have shown that the features selected are important when it comes to phishing URL classification, and have tested my approach using real-world datasets from PhishTank for unsafe links and Jasmine Directory for safe links. I have shown that my proposed approach can correctly identify phishing URLs with an accuracy of 91.269% using just features available in the URL itself. Overall, among all the classifiers tested, Random Forest performed the best in terms of accuracy, coupled with low MAE and RMSE rates.